Let's now go through a few exercises, and along the way, I'll show you some things about the principled shader. Starting off with Darth Ducky, right here. We're going to make this black rubber material. Ignore the beak for right now. We can make the beak if you want, but I'm going to focus on this really matte rubber thing right here. And the first question, whenever you're observing materials, is this a dielectric or is it a metal? Basically, if it's not a metal, then it's a dielectric. In this case, rubber is not a metal, and so that's going to inform our decisions here in a second. In Houdini, let's go ahead and create a base color for this. We'll select that, and in order to sample from an image, we need to go here, load in the image with this icon. I've already done that right here. And then if we hold down Alt, middle mouse, that'll pan, Alt, right mouse will zoom. And so now we have Darth Ducky right there. Go ahead and click this eyedropper and then find an area that doesn't feature a highlight. So right along here would probably be good. There we go. So now we have something that's about like that. Next up, we want to take a look at the specular value. I haven't talked about IOR yet, and I will get to that here very shortly. For right now, just know that for dielectrics, usually the IOR is 1.3 or 1.4. In this case, I'm going to say 1.4. Once you have that, we already have the base color, the albedo multiplier to account for heat. Now we just need to pretty much use the roughness, and we have the shader. For the roughness, I'll do a value of about 0.5. And that'll give us that matte look right here. And that's pretty much what the rubber looks like. If you're ever wondering how to set this roughness value accurately, one great way of doing that is paying attention to the reflections on the surface as they reflect an area light. So in this case, a roughness of 0.5, we can't really make the area light's shape out of anything. It's blurred out too much. We really can't define where the area light is. However, if I turn this roughness to, let's say, 0.1, now we can obviously see where those lights are. And let's actually just exaggerate that real quick. We'll go here to key lights and then take our exposure up to about 3. So now we can really see these lights. And like I said, if we just keep on bringing this roughness value up, so 0.2, it's going to start blurring out more and more. And with the rubber ducky, we couldn't even tell where a light shape was at all. So 0.3 would not be enough. 0.4, we can still generally tell where these lights are, although we're getting very close. Finally, at about 0.5, we really can't tell at all where the lights are, and this correlates again with what we see right here. Might even be more than that, might be 0.6 even. But you get the idea. You just keep on bringing things up, pay attention to those reflections, and eventually you'll end up with something like this. Now on to the cast iron skillet. Specifically, let's talk about this black portion right here. And the first question we have is this a dielectric or is this a metal? Well, it's cast iron, so in this case, it's a metal. That means in Houdini, we have to do this. Let's go to our shader bot material. Under reflection, metallic needs to be a value of 1. Anytime you're dealing with a metal, go ahead and just take that metallic value and crank it all the way to 1. That's going to allow about 40% of the surface to reflect in a specular way. And it's also going to tint the specular highlights according to what we have here in the base color. For the base color, let's go ahead and move over to the skillets and sample something right around here. So we'll do that. The roughness, I can tell a little bit where this light is coming from. I can kind of make out the shape. I'm guessing this is at about 0.35 to about 0.4. So let's say roughness of 0.35. And what we have here is very close to what that cast iron skillet is doing, but it's not quite there yet. And that's because whenever you're working with metals, you have to get this IOR value correct. So in order to do that, there's a couple of websites that you should know about. Refractiveindex.info, this is going to give you the most detailed breakdown of what the IOR will do. And so if you go to this 3D data for 3D artists right here, I chose metals and I found iron. We have all of this stuff. Here's the refractive index, and that is going to be a value of 2.9304. For now, just know that this is the IOR value that we're looking for. And if you can't find it on refractiveindex.info, then maybe check out this list of objects. That's pixelandpoly.com. If you press Control F and you look for iron, there it is, 2.95, which is just about what we have in here. I'll get more into this here in the future, but for right now, just know that that's where we can find our number. And there we go. After plugging in 2.95, we end up with something like this. Now, of course, the results will vary based on your lighting setup, but this pretty much replicates what this pan would do. Okay, now on to the mirror aviators. The first question is this a dielectric or a metal? Now, your first instinct might be dielectric, and that's because we're working with glasses. This is made out of glass, right? And glass is not a metal. So if we go by that logic, we need to go down, turn our metallic to 0 right here. Our IOR needs to go back to about 1.4 or so. The roughness down to 0. And as you can see already, this is not going to give us what we're looking for. So it's not a dielectric. We can't do that. We still have very sharp reflections, but that's not quite exactly what we have in mind when we think glass, in this case. So instead, let's just look this up real quick. Many times you just have to Google, what is a mirror made of? And we could take a look at here. We have silvering or spraying a thin layer of silver or aluminum onto the back of a sheet of glass. And so when we take a look at these mirror aviators, what we're actually seeing here on the surface is a thin coat of aluminum or silver. So with that in mind, it's actually metallic. Now if we go back to Houdini, let's go take our metallic up to 1, like that, and look up the IOR for, it's probably tin, honestly. So if we look up tin, we have it, okay, so probably tin iodine right here, so 2.1. That should give us about what we need. So we'll say IOR of 2.1, like so, and there we go. Now we have pretty much those aviators. The moral of the story here is that oftentimes you need to research what it is you're actually looking at. So you might think glass, but, well, you know, in this case, it was actually tin or silver that we were taking a look at. So there you go. That is how you might go about that. Okay, next up. Let's figure out this teapot. Now in this case, what are we looking at here? Is it a dielectric or a metal? Well, if we think about this glossy coat right here, that's not really a metal, so it's going to be a dielectric. As a matter of fact, this is probably made from some sort of clay, and then it's just coated with this super shiny coat. Now, we do have a clear coat section in here. I'm not going to be covering that at the moment, but with just the things we know, we can get the shader pretty closely. In this case, dielectric, so metallic, 0. IOR, bring that down to about 1.4. The roughness can stay about 0. And now, if we go to our base color, sample an area that doesn't have a highlight. So right about there. And there we go. Within a few seconds, now we have our sweet little blue teapot going on. And I can bring these key lights in and out of here by adjusting the spec multiplier. That's how I'm doing that. Okay, we have the teapot. What's next? Now let's try this bronze little bird thing right here. The tricky thing about this guy, we know it's a metal, so let's actually just start off by going to metallic of 1 right there. Notice how the highlights are blue as well. Anytime you take that metallic to 1, you're going to color the highlights more intensely with this base color. And if we try to sample a color somewhere around here, you'll notice that it's not going to work so well because this highlight is really different than what we have along here. And so if we go to an area that might have a patina on it, you can tell it's just not really the right color. Let's also take the roughness and bring this up to about 0.45. So we'll make this into a rougher metal like that. But as you can see, we're getting close, but it's just not quite there. And it's hard to sample an area to get an accurate color. So here's a really cool trick. If you want this color really quickly, it's not the most scientifically accurate way of doing this, but check this out. Just sample a highlight right here, go down in the value, and then bring down the saturation. So we'll do something right about there. Bring up the value a little bit more, take a look at the brightness of this highlight and compare that to this highlight. We'll bring up the saturation just a tad bit more, and then all of a sudden you have just about what that metal is doing. So, not the most scientifically accurate way, true, but it's a great way of quickly getting somewhere that you need to be. In the next video, let's make that leather jacket and then also talk about the principled shader and how that ties into all the theory we just learned about.